Okay, let's go ahead and start with section 9.6. It's on percentage and mixture problem solving. This is also really helpful everyday math skills when it comes to going to the grocery store or buying anything, sell items, etc. You can check whether the sale price is actually as it's supposed to be, or you can just figure out how much something will cost if it's marked up or marked down, in particular if it's marked down, and if it fits your budget. So in this case, we're going to do percentage problems, and I know some of you have done percentage problems differently. So I'm going to do the first one two different ways. But then I'm going to do the rest of them the direct translation method, because that's kind of what we're moving on to. You can always remember, I think it's much easier to remember the direct translation method than it is to remember a ratio method. So in this first example here, example A, 5%, remember percent means per 100. So we just translate 5% as 5 divided by 100. The word of translates always into multiplication. So this is literally a direct translation, just reading from the left to the right. 300 is, of course, 300. Is becomes equal, and x is the number we wish to find. So there's a lot of ways you can solve this. I'm going to go ahead and simplify. Well, there's two. I've got so many different minds, but I think the easiest here is just to realize this is the same as 5. Turn my 300 into a fraction and just multiply across. So it's 5 times 300 divided by 100. And all of this is equal to x. But 5 times 300, if you want, you can say, well, that is 1,500 divided by 100, and that's equal to x. And whenever we have trailing zeros, we can cross them out. So the answer is that 15 is equal to x. There's a lot of different ways you could have done that one. That's one way. The other way I was thinking about doing it was just going 5 over 100 times 300 is equal to x. And we're going to clear denominators. That means multiply both sides by my only denominator. Both sides have to be multiplied by 100. Now you simplify the left-hand side. So 100 times 5 divided by 100 times 300. So all of these are multiplication. So these cancel. So this becomes 5 times 300 is equal to 100x. And then to get x, I just divide both sides by 100. And notice that's the step I was at when I got right there, the direct method. You're going to get the exact same answer. But I did want to at least briefly mention one other really popular way to solve percentage problems. And I remember that I use this particular method all the time. And we have a formula. P is to 100, the same as the amount is to the base, where P is literally the number in front of the percentage sign. The base, how do I know what number is the base? It's signaled by the word of. What comes after of is the base. So using this ratio method, Let's go back and solve the exact same problem. So 5%, so 5 is to 100 of 300. The of means it's the base, so 300 is my base. And what is my unknown? My unknown is my amount A. So now I just solve it by cross multiplication. Once I multiply 300 up here, a 0 doesn't replace it, a 1 replaces because it's a multiplication. So that's 5 times 300 divided by 100 is equal to A. I used X for the value unknown last time. This time I'm using A because my formula amount is on the top. And either way we go, we still get that the answer is 15. And you're welcome to use this formula, although I will not be using that formula for here on out. And again, the reason being is in our previous lesson, and perhaps the one right before that, we were learning how to translate directly, literally by looking at the sentence as it is read off in English and directly translating it into a mathematical equation. So let's do number B. We're going to use the direct method. 207 is, so I'll write 207 is translates into equals 90%, and I like writing that as 90 over 100. Especially since I'm not allowed to use a calculator, I can deal with fractions easier. Of what number? That's times x. And what we're going to do is we're going to clear the denominator. So we're going to multiply both sides by the only denominator there, which is 100, times the entirety of this side. And 100 times 207 is 207, and I add 2 zeros. And over here, these 100 cancel, so I just have 90x. And now I'm ready to solve almost, because all I have to do is divide 20,700 by 90. And that's going to be my value of x. But notice that when I have a numerator and a denominator that both end in zeros, I can just mark through those zeros. What allows me to do that? I'm really dividing the numerator by 10 and dividing the denominator by 10. Since I'm dividing the numerator and the denominator by the exact same number, I still get the same fraction. So that's equal to 2,070 divided by 9. And when you work that out, that gives us 230 for the value of x. Let's go on to another problem. So again, just using the direct translation method, I'm going to give myself a little bit more space. So 15 becomes the equals 1%, that's 1 divided by 100, of what number? My number is x. Again, I'm going to solve this by multiplying both sides by 100. Why by 100? Because that's my only denominator. So that's 100 times 15 is equal to 100 times 1 divided by 100 times x. So 100 times 15 is 1500. And 100 times 1 divided by 100 is just 1. So I just have x all alone. And that is my solution. 1500 is equal to x. I would suggest that you pause the video right now and try to do number D on your own. Work it out and then unpause the video. So number D is what percent of, so what percent is P over 100? And here's the thing, when I do it that way, my P will actually be a percent. So once I'm finished, the number I get, I can just put a percentage sign on it and I'm done. So P over 100, so what percent of 350 times 350 is equal to 420. Again, let's clear denominators. There's an easier way to do it. You could simplify 350 divided by 100 if you want, but let's just work on clearing the denominators. If you want, you can turn that into a fraction. So the LCD of 101 is 100, so I'm going to multiply both sides by 100. That's the important thing, is you have to multiply both sides times 100. You don't have to put it over 1 if you don't want to. The sooner you get used to not doing that, it's one fewer step you have to do. So over here the 100s cancel out. So P times 350 divided by 1 is the same times P times 350, which is the same as 350 times P. And that's equal to 420 times 100. That's 420 with 2 extra zeros attached. So my value of P is equal to 4,200, or sorry, not 4,200, but 42,000 divided by 350. Again, I can take off 2 zeros immediately, so I just have to divide 4,200 by 35. And when you do that, you're going to get an answer of, we're on number D, I've already worked this out, you're going to get an answer of 120. And that's 120%, because we were solving, when I write my value is P over 100, my end result is going to be a percent. If I just solved it for P, then my end result, and I did not divide it by 100, then I would have got P in that scenario, it would be 1.2, in which case I would have to multiply it by 100 to get 120%. So just keep that in mind. If you represent your percentage by P divided by 100, your end result, you immediately just add your percentage sign on and you're good to go. If you don't divide it by 100, then your end result would be something like 1.2, in which case you would have to multiply by 100 at the very end to turn it into a percentage. So the next thing is we're going to do a discount and markup problem. So let's look at some basic common sense equations. So the sale price of an item is equal to the original price that doesn't look right to me. I'm misspelling that. And yes, it's bothering me, so I'm going to change it. The sale price is equal to the original price minus the discount. So that's just common sense. I'm actually subtracting some non-zero amount from the original price. But the discount, this part right here, is equal to the percentage of discount times original price. So these are two important formulas. This one, the sale price, you already know that one. It's this one right here that you might want to keep in mind. So let's use these formulas and work this out. So we have a going out of business sale, problem A, going out of business sale, and the discount is 75%. So if a original item, find the discount and the sale price of an item originally priced at $130. So let's find the discount first. So the discount is equal to 75 divided by 100 times the original price, which is $130. So that's going to be equal to, once you do your math, I would just do 75. I would take off these two zeros. Now I would calculate 75 times 13 divided by 10. And that turns out to be equal to, $97.50. That's a lot of money. But let's stop and let's think about whether that makes sense. If the original item was priced at $130 and it was discounted 50%, then the sale price or the discount would be $65 off. But now I'm getting $97.50 off, and that's more than $65. Why? Because this is a 50% discount, but this one is a 75% discount. So this number, it's a large number, does indeed make sense. So I have calculated the discount. So using my sale price, I can find out what it is. So the sale price is equal to the original price, which is $130, minus the discount, which is $97.50. And that turns out to be, wow, you're really getting a bargain here, $32.50. So let's do another one. So here we have tipping. So we have the following really simple equations. So the total meal price is equal to meal price before tip plus tip amount. That's just common knowledge. It's a common sense equation. But what is the tip amount? Well, that's what we have to figure out, but it's not really difficult at all. The tip amount is equal to P over 100 times the mill price before tip. So if an anniversary dinner cost $145.23 including tax, that's the mill price before your tip. So let's find out our tip amount. So our tip amount, and you want to leave a 15% tip, is 15 over 100 times 145.23. So this is times right here. Sometimes I don't like using the dot so much when I use decimal numbers because there's too many dots going on. And I'm absolutely fine that you break out your calculator for this one. Why? Because you want to do it right. So the tip amount actually turns out to be $21.78. That's our tip amount. So the total mill price is equal to the price before tip plus the tip amount. And this you can do easily in your head. 3 plus 8 is 11. Carry. So that's 3 plus 7, which is 10. Carry. 1 plus 5 plus 1 is 7. No carry. 7. 177. Sorry, there was no carry there. It should be 6. 167.01. It's a pretty expensive meal. Maybe it's your anniversary meal. So let's move on to the next page. Okay, so here we have percent increase and percent decrease. So here are the formula. I'm just going to give you the percent increase, and it's easy to derive the percent decrease. So percent increase I want to see which number. Yeah, let's do that one. Percent increase. So the end result is actually going to be a percent, is equal to 100 times the amount of increase divided by the original amount. That's just the formula. And we need to know the amount of increase, the amount of increase is equal to the new amount minus the original. And by original, I mean original amount. So let's figure out this problem number 3A. So the number of minutes on a cell phone bill went from 1,200 minutes in March to 1,600 minutes in April. find the percent increase. Round to the nearest whole percent. So let's find the amount of increase first. Well, that's equal to the newest amount in time minus the original. So that's 1,600 minus 1,200. So that's equal to 400. And the original amount, just to remind ourselves, is equal to 1,200. So the percent increase is equal to 100 times our amount of increase, which is 400, divided by our original amount. Now all I have to do is simplify. I'm going to simplify what's in parentheses first, and I'm going to take off those zeros. So that's 4/12. So that's equal to 100 and divided by 1/3, which is equal to 33.3%. Since I have that factor of 100 in my formula, the end result is already going to be as a percent. Okay, so now I'm actually going to erase this work over here, because I want to modify our formula for slightly. Don't quite want it that big. Instead of doing percent of increase, we're going to do percent of decrease. And almost everything is going to stay the same. But this is going to be percent of decrease. That's our amount of decrease over the original amount. But our amount of decrease is equal to original amount minus final amount. So that said, let's actually look at the problem that we're asked to do that's going to use that. Here we go. It has to do with enrollment. So in 2004, a college campus had 8,900 students enrolled, and later on, the same college had 7,600 students enrolled. Find the percent of decrease. So we have to find the amount of decrease first. And the amount of decrease is the original amount, which is 8,900 students, minus the final amount, which was 7,600. And that's actually equal to 1,300 student decrease. So the percentage of decrease, using this formula right here, is 100 times 1,300 divided by our original amount. So it's always good to take a note what our original amount was, because if you forget your original amount, you'll get it wrong. And the original amount was equal to 8,900. And I'm telling you this because that's a very common error I see, is you get everything right, but then instead of putting the original amount under as the denominator, you put the final amount, and you're going to get it wrong. So all we have to do is simplify this. Again, I'm going to tack off 2 zeros. So that's 100 times 13 divided by 89, which turns out to be 100 times 0.146, which is equal to 14.6%. Again, remember, since there's that factor of 100 right there, our final amount is actually a percent. No need to do further conversion. Okay, that's it for this lecture. It's kind of review for some of the things we did in 0018, so I hope you remember those. And if you're new to this, I hope the explanation was pretty clear. If not, just hit me up with an email. We'll do something so I can help you out, whether it's me working out a video specifically for you for a specific problem or whatever you want. I'm here to do it. So be safe and keep studying.